This is a tensegrity structure that models the human spine. And what's going on here is these are just pieces of balsa wood that are glued at this joint. And there's 4 of them. 1, 2, 3, 4. And there's string. So there's string running down every one of these edges. There's 4 edges here. And then there's string running across these 4 posts. But the 4 posts are shared. These 2 belong to the top element, and then these 2 belong to the bottom element. And hopefully you can see that the string makes an angle relative to the plane of these 4 posts. So this is forming like a little hammock that when you push down here, these strings get tight and prevent these from compressing. And when you pull on it, these strings get tight and prevent it from expanding. And then in a top view, the strings around the perimeter also give it torsional rigidity. So the structure, at least right now, is almost rigid, and yet it's just using string and tension to carry the majority of the loads. The balsa wood carries only compression loads, and the higher tension loads are carried in the string. And this is kind of unusual because most people think that the vertebrae of your spine actually push against each other when you're standing up, but in reality they don't. There's very little load at the joints of your spine because the tendons and muscles form a structure like this, and everything's suspended, and that's why the discs in your spine don't wear out as quick. They're not taking all that huge load under most cases. Now, if these strings were flexible, made of rubber band or muscles that could articulate, you can bend and twist the spine. This model is kind of rigid, but you can see it here. This is the way that your spine bends, is by these, one of them getting longer and one of them getting shorter. And yet structurally it's still strong in tension and compression, and it tends to not twist much. If you wanted to twist it or adjust those other variables, you could have the other pieces of string vary. So just to point out again, when we're compressing it, only these perimeter strings get tight. And when we're tensioning it, only these outer perimeter strings that are in a straight line, only those get tight. And it's really kind of an amazing way to build things. There's a whole field of engineering developing around this. And a lot of the joints in the human body are built this way. People didn't realize this until probably within the last few decades. Anyway, it's very interesting.